Which of the following functions is a polynomial? It's easier to actually answer this question by using a process of elimination. So we know and we have learned that if you're a polynomial, it means it's an equation that does not have a negative exponent, it doesn't have an exponent that is a variable, and it doesn't have absolute value. So it consists of, yes, variables and coefficients, but used in operations like addition, subtraction, multiplication. So I can immediately cancel out D because I see an absolute value, and I can cancel out B because I see a variable in the exponent position. But now what is the correct answer? Well, remember this is logarithmic form. So if I change this g of x into y, it looks like this. Again, this is logarithmic form. I can turn it into exponential form, an equivalent and equal form, by remembering this is the base, this is the answer, and this is the exponent. So this is equivalent to 3 to the y equals x. And now, looking at this option for A and this option for B, I see that I have a variable in the exponent position, making it not an example of a polynomial function. If you know that two particular functions are going to combine to equal x subtract 4, then which of the following is a possibility for specifically what h of x is equal to and what k of x is equal to? So again, we're going to use process of elimination. I know that when I combine just the x's, I need to end up with 1x. So I'm going to try to do the least amount of work, knowing that this is a multiple choice question. So let's look here. When I combine them, when I add them together, do I end up with only 1x? So 1x and 1x would give me 2x. Cancel. 3x plus 2x is 5x. Cancel. 3x plus negative 2x is a 1x. Now it's possible that's the only option that has a 1x, and then I don't have to do any more work. Let's check with option D. Negative 3x plus 4x, again, why am I adding? Because I see that up above, is again 1x. So I know it's option C or D. I have a 50% chance of getting this right. Now when I combine the constants, I need to end up with negative 4. Negative 5 plus 1 is negative 4. And 5 plus negative 1 is positive 4. Let's look up above. I want a negative 4. Correct answer. If the equation h of x equals 2x squared plus x minus 4, and k of x equals 5x minus 4, then what is the result of h times k? So I'm going to write out h, and I'm going to write out k, and this is just kind of a lengthy process of distributing. So I'm going to get 6 different terms when I distribute, just so you understand. I'm going to take this times this, there's 1, and 2, and then 3, and 4, and then 5, and 6. And then I'll combine like terms. Here we go. 2 times 5 is 10, and there's a total of 3 x's, 1, 2, and 3. 2 times negative 4 is negative 8 with an x squared. Now onto the x. 1 times 5 is 5. There are 2 x's. And 1 times negative 4 is negative 4 with 1x. Negative 4 times 5 is negative 20 with an x, and negative 4 times negative 4 is a positive 16. What do I do with all this? I'm going to combine like terms, and then I'm going to do the least amount of work since it is multiple choice. There's only one term here that has an x cubed. Let's check. Only one answer starts with the 10x cubed because they are written in standard form. Correct answer is B. I don't even need to go through the process of statement best describes the roots. Remember how the words for roots would be solutions, x-intercepts. X-intercepts are when they're real, of the following function. Well, I plugged it into, notice by the way, I should get 2 answers, okay? I should get 2 answers. I plugged it into Desmos for myself so I can analyze what it looks like, and I can see it never crosses the x-axis. That means there's no real. So if there are no real, anything that talks about real, I get to cancel out. No, there's no reals. So what is left then? There would be 2 imaginaries. Those are those complex solutions like a plus bi. That's a generic, maybe 3 plus 2i, something like that. Whenever you get imaginary, also called complex roots, they're interchangeable terms. That means when we look at a graph, we never see these on a graph in terms of as being an x-intercept. No x-intercepts. This represents the number of solutions. Again, since there are no x-intercepts, it means both of them must be imaginary. Select which equation below has solutions of x equals 2 plus 6i and x equals 2 minus 6i. So remember, I can see that this is in the form the a plus bi, so it's complex. That means on a graph, it will not show up as being an x-intercept. So I'm going to first see what can I eliminate here. If any of these happen to have an x-intercept, they get to be eliminated. So I'm going to look at the first one. When I look at there's no x-intercepts, that means there are going to be two imaginary solutions. So here is option A. Again, I can see there's no x-intercepts, which means I know option A could possibly be the answer. I'm going to go to option B. Option B also does not have any x-intercepts. It could possibly be the answer because I know there exists two imaginary solutions. Option C looks like this, and I can see in this problem there exists two x-intercepts, and since there are two x-intercepts, I know those are real answers, which allows me to eliminate option. Checking on option D. Option D also has two x-intercepts, so these two solutions are real, which means I get to eliminate option D. So I only have two choices. Now, how do we solve this? Well, we have a couple different choices right now. We can try to solve by using the factoring method, but as we know with factoring, unless we have a cubic, when we get to this point, if we can't, factoring is going to give us the real answers. So I know that if I have something like this, I'm going to have to use the quadratic formula or completing the square if they have a complex solution. So you do have to have this memorized. So I'm going to try A first. I'm going to replace all the B's with a 4, all the A's with a 1, and all the C's with a 10. So B squared here is going to go on the inside, and this will become negative B. So it's opposite of your B. Plus or minus. Then I have B squared, which is 16, minus 4AC, all over 2 times A, 2 times 1. And I'm going to continue to work this problem out. I'm looking for a perfect square that divides nicely into 24. So I check with 16. That's the first perfect square. Below it, no. 16, 9, 4. 4 does divide nicely. 4 times 6. Okay, now remember this 2 has to be shared with both the left and with the right. Now, though I have a square root of 6, I know this is going to reduce down to negative 20, but if I look up above in this problem, the real portion of the complex is not negative 20. What does that mean? It means now I'm going to try B to make sure for option B, the work will be exactly the same, but now the B is negative 4. That is the only difference. And just like the last problem, we know that this breaks into 4 times 6. And the 2 has to be shared with both sides. Four divided by 2 is 2, so I have 2 plus or minus I radical 6. Now, this is when it's compressed together, but I can rewrite this as 1 time adding and 1 time subtracting. That's exactly what happened here. Correct answer. Which complex number is the product of this? So I'm going to do FOIL, front, outside, inside, last. Multiplying the fronts, 2 times 2 is 4. Multiplying the outsides, 2 times -5 is -10, attach an I. Now the insides, 3 times 2 is 6, attach an I. And finally, 3 times -5 is -15, and you have 2 i's. Remember that I squared is the same as -1. So -15 times the -1 is a positive 15. When I combine like terms, the 4 in front and the positive 15 in back combine to give you 19. The -6 and the -10 and the positive 6 would be a -4. This is written here in standard form, a plus or minus bi, so the imaginary part is last, the real part is first, and the correct answer is the following is the solution to this inequality. So we want to know what x values can we plug in on the left-hand side, and the answer then, after we input in x values, would be less than or equal to 8. So I'm going to start by simply moving the 8 to the opposite side and turning this into an equation. So when the 8 comes over, I have x squared minus 2x, and I move the 8 over, and it's a -8. And this is what I have right now. I'm turning it into an equation here. And keep in mind that if I rewrite this and I put the y in front, that, like, think of this as an alligator mouth, it still has to face the y. So this output had the greater than symbol faced towards it. So when I rewrite it, again, the y has to have the greater than symbol faced to it. I'm going to now put this into Desmos, and let's see what this looks like. So I have y is greater than or equal to, remember that means we include those endpoints, x squared, subtract 2x minus 8. Okay, so this is what we're looking at. So remember, we specifically in this problem are wondering about the x values. What are the solutions are the x values that you can plug in? So when I look at the graph, I'm not concerned about what's up here or what's down here. I'm only concerned about the x values along here. So I can see that one point is at -2, another point is at 4, and then everything in between there would be the answers. Everything in between would be the answer. So if I come over here, -2 is working and 4 is working, and I have to include them, means the correct answer is A. Which of the following is the quotient? Remember, this goes inside the division box, and this is on the outside. 1 times what is 2? So 1 times 2 is 2. And how many more x's do I need to add to come up with 3? So within the x squared column, I'm going to write down a 1x squared. Now when I multiply, I better get 2x cubed if I did this right. 1 times 1 is, 1 times 2 is 2. And I have a total of 3 x's. 1, 2, 3. 1 times -2, 2 times -2 is -4. Again, 2 times -2 is -4 with an x squared. Once you get the number up top, then again, I'm going to change the signs and everything in the second row. So it was positive, make it negative, it was negative, make it positive, and now combine downwards. The front two are going to eliminate themselves. 4 and 4 is 8. I got to see once again what this. Now that I've combined, I bring down the next term of -5x. So start again. 1 times 8 is 8. I need a total of 2 x's, so I need to attach one more on. Now I have 1 times 8 is 8 with 2 x's. 8 times -2 is a -16 with 1x. Again, everything in the second row changes signs, so negative and positive. And now I combine. These two cancel out. They're eliminated, and taking 5 away from 16 is 11. And bringing down the last term. 1x times 11 gets you 11x. And I have 11 times 1x is 11x. 11 times 2 is -22. Change the signs. And now add down. What does this mean? It means this is your answer, but we have the remainder. How do we write the remainder? I'm going to add whatever the remainder is over the original denominator, which is x minus 2. This is the entire answer. 2x squared plus 8x plus 11, not 11x plus 11. Okay, so I'm looking at these two, plus 28 over x subtract 2, just like we see it. Correct. find h of x subtract k of x when we're given the actual equations. So there's a couple different ways to do this. I'm going to put it in parentheses and write down h of x and k of x, and now I'm going to distribute the negative to everything that is everything change sign. I'm going to go through what I have on the left and now what I have on the right, and I can combine like terms. So I'm going to start with cubes. I know 8 subtract 5 is 3 with an x cubed. Negative 6 and positive 4 is a negative 2 with an x squared. Negative 7 and negative 3 combine to give you negative 10 with an x. And 3 and 9 is a positive 12. In problem 10, I'm asked to multiply h of x and k of x. So to show you how to do this, there's going to be 8 terms. I'm going to take this number times the first, and then the 2 times the first term, then times the second term, times the second term, third term, and fourth term. So here we go. Negative 1 times 1 is negative 1. There's a total of 4 x's. 1, 2, 3, 4. I'm going to take this 2 times the first term. Positive 2 times 1 is 2 with an x cubed. Okay, so I've taken care of that. I'm going to cross it out so I don't get confused. Negative 1 times negative 4 is 4. There's a total of 3 x's. 1, 2, 3. And positive 2 times negative 4 is negative 8. And attach the 2 x's. Again, I'm going to cross this out so there's no confusion. Negative 1 times 5 with 2 x's. 1, 2. And 2 times 5 is 10 with 1 x. Negative 1 times 2 is negative 2 with an x, and 2 times 2 is a 4. Okay, but we can't just leave it like this. We need to write it in standard form after we combine like terms. There's only one term that contains an x to the fourth. Done with it. I'm going to circle anything that has a cube. 2 and 4 is 6 when you combine with an x cubed. Squares, negative 8 and negative 5 is a negative 13 with an x squared. And 10 minus 2 is a positive 8 with an x. And finally, the constant is a divide, and then enter the expression using the multiplication statement. So this is a little different than we are used to writing our final answer. If I could go back up here and use this example from number 8, if we were asked to divide here and write this as a multiplication statement, what it means is that you're going to take whatever you have up front, so this would be written as x minus 2, and whatever you have on top, and you're saying, oh, but you got a remainder, plus 28. This would be an equivalent answer to this. This would be an equivalent answer, okay? But this particular problem down below says, write this as a multiplication statement. So I'm going to start with x subtract 2 outside, 2x cubed minus 6x squared plus 5x minus 7. Let's review again. So 1x times what gives you 2x cubed? That's going to be 2x squared. I'm going to multiply first, then change the signs, and then add down. 1x times what is a negative 2x squared? That's going to be a negative 2x. Multiply, multiply, change the signs, and now add down. 5 and negative 4 is 1. 1x times what is 1x? That's a positive 1. So I'm going to distribute the positive 1 to get 1x minus 2. Again, switching the signs in the second row and adding down. Okay, now we need to write this using a multiplication statement. So whatever I have up front, multiplied by what's on top, making sure to leave both quantities in the correct parentheses. And then because I have a remainder, in this case it's going to be subtract. This in standard form, I'm going to take this quantity and I'm going to write it 4 times. A common mistake when asked to write this in standard form is students want to take this 4 out front, or excuse me, the 4 as the exponent and just apply it to the x and apply it to the 2. So a lot of times I see students giving me this as their final answer. Not true. This means write this entire quantity 4 times. Now, can you see how this is the exact same thing as this? They're exact same things. And I'm still multiplying each one of these. So I'm going to figure out what this is, and then I'm just going to write it again over here, because this is equivalent to this. Here we go. So I'm going to FOIL. Front, outside, inside, last. Front, outside, inside, last. So x squared plus 4x plus 4. That's what I get from these two, and since these are the same, I know this will also be x squared plus 4x plus 4. Now, I need to do this a lot of times. I'm going to take this quantity times the first, times the first, times the first, and then quantity times the second, times the second, times the second. There will be 9 terms, and then times the third. So here we go. 1 times 1 is 1, and you have 4 x's. 1, 2, 3, 4. 4 times 1 is 4. And there's a total of 3 x's, 1, 2, 3. 4 times 1 is 4, and there's 2 x's. So I've taken care of the first term, and I'm going to eliminate it so there's no confusion. 1 times 4 is 4. There's 1, 2, 3. 3 x's. 4 times 4 is 16, and 2 x's. And 4 times 4 is 16 again with 1 x. Lastly, it's just the positive 4 in the back. 1 times 4 is 4 with 2 x's. 4 times 4 is 16 with 1 x. And 4 times 4 is 16 by itself. Now combining like terms. So there's only one term, remember in standard form, one term with an x to the 4th. I can cancel it. I'm going to circle everything with a cube. So 4 and 4 would be 8. X cubed. Done with those. Now squares. So 4 and 16 is 20. And 20 and 4 is 24x squared. Now just x to the first, 16 and 16 is a 32x. And lastly is the constant 16 by itself. When we're asked to solve, we can first attempt to solve this using using factoring. Factoring will be the easiest way, but not everything is factorable that has answers. And then I can go to either using completing the square or quadratic formula if that doesn't work. So 1 times 10 is positive 10. I'm looking for two numbers that combine to give me 10, and that combine to give me 3, and then are going to multiply to give you 10. So 1 and 10, no, and 2 and 5, no. It doesn't matter if these are both positive or both negative. I'm not ending up with 3. So what do we do next? I'm going to use the quadratic formula. A is 1, B is 3, C is 10. A is 1, B is 3, and C is 10. So negative B, negative 3 plus or minus, 3 squared is 9, minus 4AC, all over 2 times A. 9 minus 40, all over 2. I know 9 minus 40 is a negative 31, all over 2. The negative sign sneaks out and becomes imaginary. And I know 31 is prime. It cannot be broken down any further. And so I'm fine with this being the answer. You sometimes maybe see it broken apart like this. Negative 3 halves plus or minus the square root of 31i over 2. In this problem, we are asked to solve to find out what input values of x would allow me to plug in those values, and this combined total will always be greater than or equal to negative 5. So the first thing I'm going to do is I'm going to move this 5 to the opposite side. When it moves over across the inequality symbol, it changes symbols. 2x squared plus 11x plus 5. All right, and now I'm going to substitute for 0, I'm going to substitute it to be a y. So now I have a function that I can graph. Now when we plug this in, we normally have the y on the left-hand side. So there's the y, 2x squared plus 11x plus 5. Now notice, this time the y has the less than symbol, or the point facing the y. So when I rewrite it, it's very important. If you don't do this, it will be wrong. It's very important when you rewrite it, the point is also facing the y. So let's look to see what this graph looks like. I've already taken time to plug it into decimals. I'm going to look to see the roots. They occur at 5 and at 0.5. Okay, at 5 and at 0.5, but notice it's everything to the left and everything to the right. It's not in between them. That's a key factor here. It's not in between them. Write this out. Remember, it's going to be negative infinity all the way to negative 5. And we're also going to have negative 0.5 to positive infinity. I want to make sure that's correct. So everything on the left from negative 5 to the left, and everything on the right from negative 0.5. Oh, and I have to include them. That is the key. I have to include those endpoints because I see a line underneath that says include. It's part of the solution set that would make it true. I'm going to come back one more time to my graph just to make sure that's correct. And there's our negative 5, everything to the left. There's our negative 0.5 and everything to the right. Again, in between is not the highlighted part for this particular problem. Let's talk about i's, imaginary numbers. Remember that I squared is equal to negative 1. Keep that in mind. So I'm going to go through this. Well, any number, regardless whether it is, any number raised to the 0 power is 1. And I to the first, well, if you take 2 to the first is 2, 3 to the first is 3, 4 to the first is 4. I to the first is I. I know that I squared is negative 1. And now if I break this apart, remember I to the third is the same as I squared times I to the first, because there's 3 i's there. And I know I squared is negative 1, and then I have an I left over, which is negative 1i. I to the fourth is the same thing as I squared and I squared. Why? Because 2 and 2 is 4. And each one of these I squareds is the same as negative 1. So negative 1 times negative 1 is 1. I want you to look at this pattern here. Keep looking at this pattern. Now, I to the fourth, okay, or I to the fifth, okay. So I to the fifth is the same as I to the fourth. Let's keep looking at the previous one. It's the same as I to the fourth, but there's one more I, right? 4 and 1 is 5. And we know that I to the fourth was 1, and then there's additional I, so 1I. And I to the sixth is the same as I to the fifth, plus an additional I. I to the fifth was 1I, but then you have this additional I that needs to come down, and now you're left with 2 i's. You have 1 and you have 2 i's. And remember, I squared is the same as negative 1, so now I have a 1 out front, and this turns into a negative 1. Look at the pattern. I'm going to write it here. So I have 1, 1i, negative 1, negative 1i. Starts again. 1, 1i, negative 1. Guess what the next one's going to be? Negative 1i. Starts again. So you're going, what goes here? It's a continual pattern. Is it always like this? Yes, it is. So I've already finished the pattern, so I start back again with 1. 1, 1i, negative 1, and I know that I to the 11th is the same as negative 1i.